All right, so the arc length formula in parametric equations, we're going to take the derivative of the x equation with respect to t and square it, and then we're going to add together the derivative of the y equation and square it, and take the integral with respect to t. So remember, way back when I did proof, this was the integral to find arc length when y was equal to an f of x. So I could go through and prove it. I'm not going to, but this is how you would move from here to here. All right, so there's a similarity, I guess I'm trying to point out. So let's go find the derivative of the x. So that's 2t, and I'm going to square it. The derivative of the y, so it'll give me 6t squared, and I'm going to square it. And then I'm going to do 0 to 2. So 0 to 2, so let's multiply this out. 4t squared plus 36t to the 4th dt. Only 2 terms, so there's not going to be a square inside the square root. But what if I try to see if there's anything that will factor out? I think there is. So I think I can factor out 4t squared. So I'm just going slowly here. So this turns into a 2t, plus. Now what to do? I see it, you see it. Easy U substitution. So 1 over 18 du. Oh dear, what happened there? Should be just a t, right? T dt. All right, so I would get a 2 over the 18 square root of u du, and oh, I lost my limits of integration, didn't I? So I can put the 0 in for the t, and I would get 1. Put the 2 in for the t, I would get 9 times 4 is 36, and 37. So this would give me 1/9, and then I would add 3 halves, 2/3, 1 to 37, so 2 over 27, so 37 to the 3 halves minus 1. All right, here's a little one that's going to be a little more challenging. And if you remember when we did arc length, almost all the mistakes were made in the very first step. So be careful in finding the derivatives. So let's just go find them separately here. So I'd bring the 1/2 down. Then it would be t to the negative 1/2, right? So this would be the same as saying 2 over root t. So that's dx over dt. All right, before I take the derivative, I'm going to rewrite this. So that's 1/3 times t cubed, 1/2 t to the negative 2. So taking the derivative, bringing the 3 down, I get t squared. So this would give me negative 1 t to the negative 3. All right. So now I'm going to put this in. So I'm whoops, that's a t. I'm squaring that. T squared minus t to the negative 3, and I'm squaring that. All right. So here I would get 4 over t, and here I would get t to the 4th. I want to make sure that's a plus sign, right? That's a plus, okay. T to the 4th for squaring this. This times 2 would give me a 2 over a t, and then squaring this would give me a 1 over t to the 6th power, right? Because t to the 3rd times t to the 1 over t cubed times 1 over t cubed is 1 over t to the 6th. All right, so I see that these two join together. So let's write these. So they give me a plus 2 over t. And now I see there's 3 terms in the radical. So I'm thinking there's going to be a square. So I ask myself, what can I square to get this? That would be t squared. What can I square to get this? That would be 1 over t cubed. And if I multiply this times 2, do I get this? I sure do. So it turns into, I'm just going to rewrite it as t to the negative 3 So now I can take the antiderivative, t to the -2 over -2, and plug in my limits of integration. So I'll get 64 over 3 minus 1 over 16, subtract 1/3 minus 1/2. And that's a fine answer.